solving equations, simplifying polynomials, and exponent rules. I like that these are put together because sometimes we don't know when to get x by itself and when not to get x by itself. On a problem like this, we don't want to get x by itself. There's no equal sign, and it says simplify. What that means is we're just going to go as far as we can with multiplication and combining like terms. So this is like those crazy problems that we did right before break where we have all these nested parentheses that the OST is very infatuated with. For problems like this, we're going to start on the inside and work out. So the first thing I need to do is multiply that 6x in. So 6x times x is 6x squared. 6x times 1 is 6x. That's the first step. We're just multiplying through that 6x. That first set of parentheses, the 10 minus 2x, there's nothing out front. Those are not like terms. So I don't need to do anything with it, but I can drop those parentheses because there's nothing to do on the inside. Now, my parentheses, I've done the multiplication I need to. There's nothing else to distribute. So now I'm just going to combine my like terms. We like to put our squares in front. We like to go in order from biggest exponent to smallest. So I'm going to put my 6x squared out front. I'm going to do negative 2x plus 6x. If you're using your calculator for that, remember you're just doing negative 2 plus 6, which is 4x. And then we need our 10, positive 10. You're not going to factor that. You're not going to try to get x all by itself. You're just going to combine like terms and be done if it says simplify. Right, next problem. Again, it says simplify, so we're just multiplying, combining like terms, and we're done. For a problem like this, we need to double distribute. So I'm going to take the 3x squared and multiply it with x and negative 4. I know I need to do this because parentheses right next to each other mean multiply, right? So I'm going to do 3x squared times x is 3x. And remember, we're adding those exponents. So x squared times x is x to the third. 3x squared times negative 4. So 3 times negative 4 is negative 12. And then I need that x squared. Now we're done with the 3x squared, and we're going to do the positive 5. 5 times x is 5x. 5 times negative 4. Positive times a negative is negative. 5 times 4 is 20. Anytime I do double distribute, I always look for like terms. With this one, since we were distributing through that square, we don't have any like terms to combine. Usually we can combine the middles, but with this one, that is in final form. So it's a little polynomial review. The next section is exponent rules. You don't want to leave negative exponents, but that's something that you definitely want to double check. Like just read the directions when you're doing the OST. On the OST, there is like you're gonna bring headphones because you guys all have earbuds. You can use them on the OST to read to you, whether it's reading a word problem to you or just directions. It's really helpful. So here we're going to take this 4 and we're going to apply it to everything in our parentheses. What we have in our parentheses is 2 to the first and x to the fifth. So before I do that, I'm going to rewrite 2 to the first, x to the fifth. And then I'm going to remember that power to a power means multiply. We just write multiply right there. It's been since before spring break that we did exponent rules. And exponent rules, remember, the only thing we did with exponents were add, subtract, and multiply. So the math is easy. It's just knowing what to do when. So I'm going to multiply 4 by both of those exponents. So this ends up being 2 to the 4th. And 5 times 4 is 20. You're more than welcome to do 2 to the 4th in Desmos. or in your calculator. Remember, you need the A to the B button to do anything besides your square here. And then 2 to the 4th is 16. So my last step here, I would make this 16 x's. All right, next exponent rules problem. We had 10x to the 9th over 5x. When we're dividing, we're going to divide our bigs and subtract our exponents, as long as we have the same base. If it was x on top, x to the 9th on top, and y to the 1st on the bottom, we couldn't do anything with those. But since they have the same base, we can subtract. 10 divided by 5 is 2. 9 minus 1 is 8. Biggest problem. So divide your bigs, subtract your littles. Remember, the only thing that we do with exponents is add, subtract, or multiply. So those are the operations that you're doing. Like this one, the only thing to do on this one is to add the exponents. So 14 doesn't have anything to multiply with. A doesn't have any like bases either, but B's do. So if we have the same base and we're multiplying, we add our exponents. 6 plus 2 is 8. All right. Select all expressions below that are equivalent to 3x to the negative 2 all to the 3rd. These are annoying because select all that apply problems are actually like 1, 2, 3, 4, 5, 6 problems in one. We've got some math to do here. So the first thing to do is this guy. So just like we did with the other power to a power problem, I like to rewrite what's in my parentheses. And then bring in that exponent. So I'm going to multiply the 3 both places. I'm going to multiply the 3 both places. So that gives me 3 to the 3rd. And negative 2 times 3 is negative 6. And I might pause at this point and look across and see if that's the same thing I'm getting anywhere else. Nope. Okay. And then what we know about negative exponents is that if we have a negative exponent, that means that that term is on the wrong side of the fraction. So we need to drop it down. So this is actually equivalent to 3 to the 3rd over x to the 6th. Now, is that one of our answers? It is. That's this guy. The other thing that 3 to the 3rd is, 3 to the 3rd is 27. I think we did that one as well. So your final answer, I ran out of room over there, is 27 over x to the 6th. So I don't see that as any of our answers. So now what we're going to do is go through and see if we can get rid of some of these options or pick any more, because it was a select all to apply. So this one is 9x to the negative 6. The only thing you can do to fix this one is drop that to the denominator. So this in final form would look like that. 9 is not the same as 27, so not an answer. Here, 12 divided by 2 is 6. X to the 4th, here we would subtract those, so that would just be x to the 1st. So that's also not an answer. 27x to the negative 6 is very similar to this right here. What we need to do to fix this is drop that to the denominator, so it would look like 27 over x to the 6th. And that is the same as our final answer was here. The last one we have to look at is E. And since all of these x's are on the same level, we would add these exponents. So it would be 9 plus negative 2 plus negative 5. I'm not really in the mood to do any math in my head right now. 9 plus negative 2 plus negative 5 is 2. So this is the same as 27x squared, which is not equivalent. So let's tell that applied problems really are not difficult. We've done all of these exponent rules, like even just today. We didn't do any new exponent rules. You really have to baby step through them now. Like it really just takes being persistent. All right, now we're going to solve some equations. Couple quick equations and you're on your way here. Number 7, the first thing we're going to do is distribute that negative 2. Don't forget about the 7 out front. So negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. You need to combine like terms before you move across the equal sign. So I'm going to do 7 plus 2 first. Don't do the opposite operation when you're on the same side of the equal sign. 7 plus 2 is 9. So negative 2x plus 9 equals negative 13. And now move across your equal sign. Subtract 9. Uh, 13, 22. Is that right? Double check. Tell me how guys I'm making a video. Thanks. Don't want to be wrong on this video. And divide by negative 2. We get x equals positive 11. The fraction-y ones are kind of the problem that we found the most challenging at the beginning of the year. So remember, the first thing to do here is try to get rid of that fraction. And a fraction is just a division problem. So if I'm going to get rid of this 5, I'm going to multiply by it. I'm going to multiply and it's going to cancel. What I do to one side of my equation, I have to do to the other. And with multiplication, I have to do it to every term. So there are 2 ways you can show that. You can either show that by parentheses to make sure that you distribute that 5 in, or you can do this, which I kind of like, times 5 times 5. Multiply it with your fraction on the one side and everywhere on the other side. So here's what that looks like. 4x plus 6 equals, whether you're distributing the 5 through or just multiplying with equal terms, 5x minus 15. And now it feels like kind of a normal equation. I would subtract like 4x from both sides first. Five minus 4 is 1x. That just keeps that x term positive. And then I'm going to move the 15. And since it's a negative 15, I'm going to cut it. 21 is equal to x. It would be lovely if a solving equation problem was number 1 on the OST, because that's what we've done. You know, that's what we did first at the beginning of the year. Can't guarantee that, but there will be some equation solving that you will do. All right, a couple more. This problem is still a solving equations problem, but now it just has a bunch of letters instead of numbers. So you're going to use the same solving techniques. I like to, on my scrap paper, I would write down the problem and then circle which variable. you're solving for. Because when there's more than one variable, sometimes it just looks like craziness. So circle what you're solving for. You don't want to switch variables in the middle. And now you want to get rid of this division first. So we undo dividing by multiplying. We're going to multiply both sides by s. So on the left side, we have dl. On the right side, we have k times s. I'm going to circle that d again, because I don't want to solve for the wrong variable. So multiply to get rid of that fraction. And now dl, that's multiplication. To undo multiplication, we're going to divide. Don't get freaked out by multiple variables. You guys can all solve equations that are much more complicated than this. And so just think about, what would you do if it was a number? Pretend it's a 5 instead of an s. What would you do with that? Pretend it's a 1 instead of an l. What would you do? How would you move it? Okay, a couple more. So the OST does seem to love fractions. The great thing about Desmos is that Desmos, like to any calculator, fractions are just other numbers. So if we want to get x all by itself, we're going to add 5/4 over. Okay. Don't be freaked out by that 5/4. I'm going to go to Desmos and I'm going to put in 14 plus 5 divided by 4. Desmos even makes it into a fraction for you. You don't have to hit a special button like you do on the TI-84. 15.25. And then divide by 5. .05. Again, don't be freaked out by that fraction and think like, yeah, that's not going to be one of my 20. Let Desmos do the work for you. You know how to solve the equation. Just go with that. Okay. Same thing here. I would move my x's first. So the x that I'm going to move is 2x, so my x's are positive. This is going to feel very like the last problem. We just have 4/5 with this one instead of 5/4. Subtract that 4/5 over. And again, don't skip it because there's a fraction in it. Let Desmos do the fraction for you. 7 minus 4/5. 6.2. I thought it was going to be worse than that. I thought it was going to be longer. I was like, I was dreading the decimal that I was going to have to write. Not so bad. Divide both sides by 5. So let Desmos do that heavy lifting for you with the fractions. Don't skip it. You know the steps. Let's go. Same thing when you have more than one variable. You guys know how to solve equations. Go with it. This is probably the most challenging solving equations problem that we've seen. If we want to solve for r, we've got to deal with the r squared. So we're going to do it at the end. Yeah, I'm sorry. So if on that last problem, see if you can get the r squared by itself first. So you're going to want to multiply that r squared to the other side. You can't solve for it if it's in the denominator. So the first thing to do is get rid of the fraction. So we have r squared times f equals g And then that's M1 and M2. Those are just variables. It can be heart and star. It doesn't matter what those are. Just copy them. We're trying to get R by itself. So I have R squared times F. So the next thing I'm going to do is move that F. Since I have multiplication, I'm going to undo it by dividing. So divide that F over. And now we don't want R squared, we want R. How do we undo a square? Square root. So what we're going to do to both sides is this. The square root goes over the whole entire fraction. And you're done. You can't take the square root of g if you don't know what g is. You actually would have to know what each one of those variables was, do that division and multiplication, and then take the square root. So your final answer just looks like that. I believe that this was, when this was on the OST, it was a multiple choice question. And I think that one of their distractors was only having the square root like over the top of the fraction. So just make sure if you're taking the square root, you do it every day. Okay, done.